Good day, everybody. We have a problem that deals with 11 independent integer variables. I guess you could think of it like that. So each of these x sub i's, and there's 11 of them, index 1 through 11 here, is another way to have stated the initial condition would be just greater than or equal to 1. I like this notation here, z superscript greater than or equal to 1. But it essentially means this: each of the integers are greater than or equal to 1, not allowing for 0 here. Okay, now what we're supposed to do right here, we're given this special condition with this strange looking constant out here, and we're trying to find the maximum value of this sum. Okay, we're trying to find the maximum value of the sum of the 11 integers. Okay, now a lot of you may have already surmised something that's going to be very important, and it comes up here. It's certainly clear that s is greater than or equal to the sum of the first 11 integers squared. But notice that has a nice form. That form is, if you recall, let's see here, what is it? 11, I think what times 11 times 1? 11 plus 1, excuse me. And then I'm trying to remember it, y'all, and I should have written it down up here for you somewhere, but it didn't. I believe it goes like this: 2 times 11 plus 1, all over 6, magic number 6. And you can prove this result by induction. This formula is used a lot in a calculus class when you're doing the limit definition of the integral. You know, and you're dealing with nice things like polynomials squared with square terms in it. But anyway, this is what that is, I believe, if I recall correctly, and I'm betting on it being equal to 506. I haven't done the computation, but I've seen this type of problem, and this is actually equal to 506. 506, just like this constant right up here, the same thing. And I'm just checking real quick if I got 132. I can't do that in my head, but I do think it's equal to 506, the same as this constant. Now, that really makes an impossible looking problem become quite easy, because this has to imply, we know it's clear that s is greater than this because each of these integers are greater than or equal to 1. Each of the x sub i's are greater than or equal to 1. So it's crystal clear that by the way s is defined, s has to be greater than or equal to I squared. And the only way you could have equality is if, and I'll just write it right up here, all of the x, let's write like this, x sub 1 equals to x sub 2 equals to x sub 3. Some people just go up to 2 on these kind of things that involve ellipses, equals to, I don't know if I should put, dots. Yeah, let's put some dots in there like that. And I'll say equal, sorry y'all, it's a little sloppy. That's equal to x sub 3. X sub 11, excuse me. Y'all, this is really bad here. But I just went up to x sub 3. I didn't want to write everything down. So it'll be all x sub 4, x sub 5, x sub 6, all the way up to x sub 11. They all have to equal to 1. And that certainly is clear just based on the forced nature of this sort of contrived problem. Okay, that the constant here, if it was anything but this, would be a very difficult problem. I don't know what you would do. Would take 11 partial derivatives and do calculus, you know, set does 11 partial derivatives equal 0. I don't know. But anyway, it's rigged to work nicely. I think this is an SMO. It's similar to some SMO. I don't know if it's senior or open, really, but I know it was an SMO problem. Maybe recently, 2025, 2024. I believe it was 2000. Recent year, okay, and I don't remember what section. I know it wasn't the junior. It may have been the senior or the open. I'm not sure. Okay, but anyway, a kind of a fun problem if you just have the sense to realize that this constant is the same as what you get when you sum the first 11 integers squared. Okay, so this is all very, very clear based on the fact that x sub I is greater than or equal to 1. So the only way you could possibly have equality here would be if this condition prevailed. But if that condition prevailed, that would mean that this sum would equal to 11. Okay, which is the answer. Again, folks, I've often wondered about this. Math prides itself in its honesty and directness and everything. But literally, this problem was rigged to work. If this is any other constant, I think this is very much the challenge. I'd like to know how that would go. I don't know if calculus would be the best way, probably. But it is maybe has something to do with integer programming, since all this stuff deals with integers and no real numbers. It's discrete in that sense, and calculus is more of a continuous variable kind of maximization scheme, although it does work in the discrete case in a lot of instances, I think. But anyway, that's the answer I got, y'all, 11. And thank you for viewing.